let's take a more specific parallelogram, the rectangle. Let's say you have a rectangle ABCD with diagonals intersecting at point E. And let's say angle BAE is 20 degrees. And let's say the last thing is AE is equal to 6. See if you can find the area for that. When you're dealing with, again, any of the areas, begin with the formula, base times height. So here, if we treat this as our base and our height, what we can do is take a look at this right triangle that's formed. Now, if this angle is 20 degrees here, what does this angle down here have to be? Right. Actually, let me go through and use a different set real quick. So when we figure out our area formula, we need our base and our height for this triangle. So we have this right triangle created here. If AE is 6, what's left, or what does that mean EC has to be? 6. Okay? Because in any parallelogram, the diagonals are going to bisect each other. So this whole length is 12. So if we were to sketch out this whole triangle, we have a hypotenuse of 12, an angle of 20 degrees, our base, and our height. Well, what we can now do is use trig ratios to find values for the b and the h. Okay, so if we want to find an expression for b, we have an angle, we have an adjacent side and a hypotenuse. Adjacent and hypotenuse is designated by which trig ratio? Cosine. So we know that the cosine of 20 degrees has to equal b over 12. Multiply both sides by 12, and that allows you to substitute in the expression 12 times the cosine of 20 for our base. We can do the same thing here to find h. Take our angle. We have an opposite side now and a hypotenuse. Opposite and hypotenuse are related with what trig ratio? So the sine of 20 is equal to the h opposite over hypotenuse 12. Multiply both sides by 12. And that allows us now to substitute in 12 times the sine of 20 for our height. Now we can simply calculate those out to get our whole solution. So if we take 12 times the cosine of 20 times 12 times the sine of 20, if we put our answer in decimal form, we get the area to be approximately 46.28. It is a two-dimensional area, so it's square units. But again, you can see that we're going to be relying heavily on the relationships from the triangle chapter, especially the right triangle stuff. Okay, let's talk about